Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward. All right, well, welcome everyone. Today we have with us Justin. How do you say your last name, Justin?
It's Reock.
Reock.
Yeah.
That's it's so close to React. I should remember that. It's been a little while since I used React.
Anyway. I should have a chance to just change it. Just go ahead and bite the bullet and change it.
Right. So I'm excited about this conversation because I feel like a lot of the episodes that we do, Bruce, hi Bruce, we're not in the same location today.
We are states away from each other.
Yeah. Technology, amazing.
Yeah.
But I'm excited because a lot of our conversations seem to have a common theme around developer productivity. And today we have Justin, who is going to talk to us about developer productivity engineering. So I love this because it seems like as an industry, for the entire, I don't know, however long, I've been in this industry for 25 years or whatever, and Bruce, you've been in it for much longer. It seems like there's never really been a sufficient focus on helping make engineers more productive. And I don't know why. Like, this seems like the most obvious thing that we could, as an industry, do. And yet we just accept that bad productivity is the way that things are, and we're not.
I would argue a little bit. I mean, it's what we do. When you go from assembly language to compilers to better languages and everything, it's developer productivity engineering. I think it's just that we're not actually talking about it. We're just going, well, of course, this new tool makes you more productive, and that's why we're doing it. But we never really.
I guess what I've seen beginning to change is that now organizations that have developers have a portion of those developers allocated to making all the other developers more productive. And I think that that's the change that I'm starting to see that is bundled under this developer productivity engineering. Like, what I want to see is every organization that has developers should have a team that does developer productivity engineering.
Or at least one person.
Yeah. So let's step back. Justin, who are you and what is developer productivity engineering?
All right. Well, thanks. Yeah. So I'm Justin Reock, as I was mentioned, currently field CTO and chief evangelist at Gradle. My background is primarily in software development. I spent a long portion of my career writing code before moving into more architecture, enterprise architecture kind of work. And then at some point, I started making more PowerPoints than applications, and I changed into kind of doing this sort of full-time advocacy work. And I really like it. I get a chance to have great conversations like this one and talk about productivity with a lot of people who are really interested in it. You made a couple of really interesting points that we haven't focused enough as an industry on productivity. I think that's totally a fair statement. And I can say that kind of full-throated because there's so many deficiencies still widespread in the tool chain that I think our industry has become a little bit numb to, right? I wouldn't say that it's as much as like an intentional non-focus as it is almost a lack of consciousness around some of the toil and friction and frustration that are kind of faced by developers on a daily basis. And I think that a lot of us who have worked in the industry for so long consider it almost like an occupational hazard of the job, that you have to deal with long test cycle times or flaky tests or, avoidable non-verification failures in the build or just general inconsistency or unreliability. But, it's funny, when we talk about some of the metrics that are important in developer productivity engineering, simple things like how long does a developer sit and wait for a local build or test cycle to complete? It is staggering how few businesses are even capturing that metric. I mean, I'll go around and talk to audiences about DP, and I love to ask that question. Hey, who in the audience is actually keeping track of local build times, putting it on a dashboard? It's crickets. It's like nobody, right? And so it's like, I wouldn't say that we haven't been thinking about productivity. I think we've been thinking about productivity in the wrong way, right? And I think that developer productivity engineering provides a technology-based and pragmatic approach for improving developer productivity by reducing toil. So it's not like one of these more management-driven activities where it's like, which I'm not saying that those aren't important. They certainly are. People management, process, all of that falls into it. But what developer productivity engineering really focuses on is removing the technical barriers and friction to productivity for developers.
Oh,
Right, and
I have so many questions.
There's science behind some of these things, like how long do you wait before your brain wanders off? Whereas if you have a tool like IntelliJ, where you do something and it immediately says, oh yeah, that's not going to work. And you go, oh yeah, that's right. And you stay engaged with the process. Whereas if you have to run something through a compiler and wait and then look, it just you just lose that focus.
And the problem is so bad that there's an XKCD comic that summarizes this perfectly. It's the sword fighting, compiling, and I think that like the fact that comic exists just shows how stuck we are in thinking that this can't be fixed or improved. Right? It's just like we just accept this as normal life.
I use that comic in probably half of my presentations because it is so, and when I put it, I'm like, it's not funny. Actually, it's poignant.
Right.
It's actually like sad that we can all relate to this. Right.
Yeah.
And it's like, Hans
it's
Doctor,
a universal experience.
It is. And it's too bad, because this is a manufacturing job. This is a production job. Now, I would argue that it's a highly creative job as well. So Bruce, you were talking about staying engaged, right? We really refer to that as creative flow, right? We see the act of writing code. And this isn't just we see it, right? It's actually been mapped. I don't know if you've seen some of these studies, but they're fascinating, where the brain has been mapped while someone's actually writing code. And it's this amazing lit up soup of left brain and right brain activity. On the one hand, you're there, you're visualizing a problem in your head. You're creatively thinking through how you're going to solve that problem. But then you do something very scientific, which is I write code, I make a hypothesis, I go into a code dialogue with my tool chain, and I'm expecting feedback. And if I don't get that feedback fast enough, then I'm breaking my creative flow. And there's a couple of, it's beyond just losing productivity at that point. There's neurological evidence, over the last 10 years or so, we figured out that humans can't really multitask. We kind of put that one to bed. And we convince ourselves that we can multitask, but it's not really true. But what we found over the last couple of years is that context switching and multitasking frequently leads to an overbuildup of glutamate in the prefrontal cortex of the brain, and actually leads to a chemical cognitive fatigue that over time can kill the innovation of a business. You can do your job if you're fatigued, right? I mean, we all do it, right? We get up, but can you
have some coffee and then that kind of fixes the problem?
Exactly, right?
But you can do a job. You can not necessarily your optimal job.
Can you elevate beyond? Can you innovate and think outside the box? You don't have the juice for it at that point. So Hans, loves to look at this and say, like, why? Hans Doctor, inventor of Gradle, my boss, why in this industry is it acceptable not to be looking at this stuff? If he loves to talk about, if he goes when he's pitching to like car manufacturing, and he asks a similar question: who's tracking local build times? He's like, well, if I went to go talk to your factory folks and ask them how long it takes for part A to get to station B or move to, like, they'll know that. They know it right off the bat. They know exactly what those metrics are. So why don't we
when you look at traditional engineering and assembly line,
because they're the ones waiting on it.
Yeah.
So that's
like this seems like the most obvious place where someone in management could show significant savings, significant impact on a business is by setting up a DPE team. And like within months, you could show we saved this amount of money. Like, it just seems like the most obvious management thing that organizations could be doing that's easily measurable, like all those things. Like why haven't we done it? Why haven't organizations done it?
It's a really good question. I think, and this is my own speculation, but I've also spent a lot of time thinking about this. Since what I like to refer to as like the ancient business wisdom times of the 1970s and 80s, when there was a lot of focus on manufacturing, when the theory of constraints became really popular, and Eli Goldratt published Goldratt equations and the goal and all these things, we've been really focused on value stream And we've been really focused on parts of the value stream that can be understood across multiple areas of the business. So I think you look at a manufacturing company and they're like, okay, throughput. What does that mean for us? Well, it means how fast can we assemble the raw materials, get them out to market, and get them sold? Okay, we understand that. It's putting stuff together, and we can easily look at this whole value stream and say,
well, and it's visual. You know, people in management can look at it and see it immediately, whereas the kind of stuff that we're doing has these weird magical subtleties that they don't.
Exactly. There's an esotericism to what we do that is harder to understand. And so it's difficult. So I think that, and then what does that mean? That means you need to rely then on engineers complaining, right? Engineers saying, oh, this build time's terrible. But they don't. Right. As a whole, we're not great about advocating for ourselves sometimes and advocating for the best developer experience that we can get or that can be provided by our business. So I think it's like we spend so much time looking at productivity in terms of a value stream and parts of things that we could understand. But as we started to fast forward into building more of a digital infrastructure, kind of the world that we live in now, the work being done by a developer is very hard to understand by the people who traditionally have been in charge of productivity for the business. Now that's changing too. To James's point, we are starting to see, folks who have been in the development organization split off, focus primarily on productivity. And the ultimate, as we see, sort of maturity step for a business that wants to be really good at DPE is to build this central team, which, by the way, is something that separates it, I think, a lot from DevOps, right? The platonic ideal of a DevOps team is no team at all, right? Pure automation and bots. Whereas I think to do DPE correctly, you really have to have somebody who's empathetic to the experience to be driven enough to cascade better practices down and then watch those metrics improve and actually care about that.
Yeah, it's interesting, the contrast with DevOps, because in some ways, the ideal end game of DevOps is for DevOps to not need to exist, right? Whereas with developer productivity engineering, it's like you could always do more, right? Like it's a surface that is infinite. Like you could always optimize the tool chains and the productivity further.
I feel like this has been, I'm fascinated with this discussion because I look at my own life and I'm going, I've always been looking for the next better tool. How do we do more with less? And this is it.
I think so. And it's a tool and a practice, right? And I think that that's really important because obviously we're Gradle. We have the Gradle Enterprise product, which is our solution for developer productivity engineering. And so we like that. We think it's a good comprehensive solution. But there are limitations, right? I mean, first of all, it's Gradle. So, it's the product does integrate with Gradle, Maven, and Bazel at this point. So we can extend a little further outside of the JVM, but not really, right? And we want to make sure that this practice is available to everyone, right? So looking at it through, I would say more of a vendor agnostic, more practice oriented lens. The focus really comes down to looking into acceleration technology to improve feedback cycle times, look into better ways of gathering troubleshooting data for developers so that when they run into issues, when the build breaks, they don't necessarily lose their creative flow state, right? I mean, a new problem, a build going red does not yank someone out of the creative flow. Oh, new problem to solve. Great. What can I do? But it's 45 minutes of drudgery trying to get all the data that you need to troubleshoot that build that can take you way out of that flow state and put you in that awful, frustrating state. So be better about gathering troubleshooting and forensic data. In the case of Gradle, that's what we call a build scan, right? But there's other ways to gather this data. Then, you kind of keep moving towards, so that's fast. Well, we also want consistent, right? We don't want to build that most of the time takes 3 minutes, but every now and then takes an hour, because developers will just say, okay, well, sometimes this build can take an hour. So I'm just going to cram in all of this code, knowing that I might be waiting an hour, creating all these additional, potential breakpoints. So we got speed, we got consistency, and then there's reliability, right? Sussing out flaky tests, detecting them, putting them on a dashboard so that they can be dealt with proactively, right? These are the types of actions that we consider being part of a developer productivity engineering practice. They focus specifically on the technology, and they put us in this mindset. They get out of the mindset of like, oh, is the build fast enough? Well, I don't know. Nobody's really complaining. Like, is it as fast as it can possibly be? given all acceleration, observation, analytics, technology, because in our mind, that's what we owe this workforce at this point. We are, and this is as of earlier in this year. I mean, this is almost a year ago old data now, but back in October of 2020, IDC predicted that 65% of the global GDP would be digitally transformed by 2022. It was accelerated in part as a result of COVID, but it came true. And let that sink in. As of a year ago, 65% of the global GDP has software in the loop. That's a tremendous amount of software, leading to a tremendous workforce. This is a workforce that's building software that as we kind of know, lifts all areas of human quality of life, right? I mean, sure, on the one hand, we get to have our cool VR headsets and smartphones and stuff. On the other hand, we get to cure diseases faster. We get to model our genome and put it into a digital twin. I mean, that just happened over the course of the last year too. We have this workforce that's lifting so many boats in the harbor. We owe this workforce an investment in their happiness and an investment in their experience. What bothers me is that we actually have known this for a long time. There was a study done in the mid 80s. I think it kind of began in the 70s and really kind of took hold in the mid 80s, called the Coding War Games. Tom DeMarcos and Timothy Lister. These were the two primary authors of the book Peopleware that came out in the.
I know those guys. Yeah.
Yeah, sure. These folks were thinking about productivity back then. The Coding War Games was this cool study where they worked with close to 100 different businesses, I want to say, maybe more than that. But they took 2 developers from each of these businesses and they gave them a coding task, intermediate difficulty. They didn't enforce the language or platform. They let them use whatever they were comfortable with, but they asked them to record the amount of time that it took for them to complete the task. And these 2 folks in the organization were not peered. They were working separately. So they're kind of competing with one another. And the idea was, what kind of vectors what kind of dimensions can we kind of look at the data that comes out of this study from? What they found was very interesting. First of all, this is probably where the myth lore of the 10x developer comes from, because they actually found that some developers were producing at around 10x the rate of other developers. But what was super interesting was that there wasn't much variability inside a single organization, right? So developers working inside the same organization were producing at around 21% of the same, which if you think about a 10x scale top to bottom, that's like it's statistically insignificant.
Noise level.
Right, exactly. So, but what they found was that they started digging in. They looked at these businesses. Now, developers were about a 10x differential. Organizations were over 11x. There were organizations that were 11x more productive than the bottom quartile of the people who took part in this study. So they started digging in a little further. What's different? Well, they asked questions like, how much workspace do you have? And the top performing people had like something like 70, 80 square feet to work in, where the bottom performing quartile were almost half of that amount of space. Right? Yeah, just crammed in. Little things too, like can you silence your big bulky conference phone that you had back then? Can you divert your calls, right? And little things like that. Overwhelmingly, the top performers had a better experience to list. And what it really came down to, what the study told us, was that productivity was all about the type of experience that was being built for developers, which should be a no-brainer, right? I mean, at the end of the day, these are still human beings, right? These aren't robots cranking out, it's a human workforce, right?
Not yet.
Not yet. Yeah. Right. Knock on wood, right? With GPT-4 on the horizon. So,
one of the first companies I worked for had a PA system that was going off all the time, and it was really kind of a status thing, because they were announcing that this salesperson had an international call or whatever, and this was being broadcast through the engineering department. And I noticed that I would come in late and stay late, and around 5 o'clock my productivity would go up, and I finally realized, that's when the PA system person went home. And finally, one of these evenings, I got up on all the desks around my desk and I cut the wires to the speakers to reduce the noise level. So that was my contribution to developer productivity engineering.
That's great. You nailed it. You were a pioneer, obviously. So
this is about how can we better keep developers in that flow state And there's many different factors to that, obviously. The environment, as you mentioned, like are developers comfortable? Are their chairs comfortable? Whatever. But then there's the tooling and the feedback cycles and all of that. I think that you're categorizing DPE into both the tools and the practice is a really good way to look at it, because yeah, we can improve the tools, but if we don't have the practice side, then how do we know we're actually doing all the right things, right? Like how do you look at the difference between the tools and the practice side?
And I would throw in on top of that culture and education.
Yeah.
Great questions. Yeah. So the practice is really more about, it's almost if you take a look at the way that space framework is laid out, where it's not really prescriptive. It's like these are the 5 dimensions, and you want to normalize whatever data you get about productivity back into one of these 5 categories or dimensions. But there's no prescription as to how you gather the data, whether it's through feedback.
What's the space framework?
Yeah.
Oh, yeah.
I hadn't heard of this. What's the space framework?
Space is a newer framework that was introduced in a paper by Nicole Forrestgren from the University of Vancouver, British Columbia, Brian Hook from Microsoft, and a number of other people who kind of contributed to this. And it's a way of sort of trying to comprehensively define the productivity of a business through a normalization model. So SPACE stands for satisfaction, performance, activities, collaboration, and efficiency and flow. And the way that the framework is supposed to work is that you gather feedback somehow from the developer organization. Sometimes it's just a simple question. Like there was a study done in April of 2022 where all they did was ask managers and developers a very simple question. How do you think about productivity in your organization? Or the managers were asked, how do you think about productivity on your team? Very, very similar. And then they would respond with a short answer. And then each sentence would be categorized. Okay, this sentence was about satisfaction. This sentence was about performance. This sentence was about activity. So it provides this very flexible way. And then a goal too. The goal is really to try to balance all 5 of these dimensions so that as a business, you're giving equal attention to satisfaction, performance, activity, collaboration, efficiency, and flow to try to come up with a balanced productivity model. And so the space framework is interesting because when you look at other things, like for instance, DORA metrics or stuff like that, those are a little bit more prescriptive. And the DORA is the DevOps Research Association metrics. These metrics were developed inside of Google and are now one of the primary set of metrics that people look at. These are things like mean time to resolution or commit to deploy, other sets of metrics. But these metrics are very prescriptive, and they're like, hey, gather this data this way, improve this thing this way. Whereas space, what I like about it is that it goes beyond, I think, the tactile parts of productivity, like how long did it take to get from point A to point B, and also explores things like satisfaction and things like overall efficiency, right? And so
that's how it relates back to like culture. Like how can culture impact productivity? And so not just looking at it through the lens of tools and build times and feedback cycles, but how often am I getting stressed out and getting blocked because my manager is, being a pain or whatever it is, right? It's like trying to identify those sorts of pieces to the equation as well, right?
No, totally. Which again, I think it gives this nice comprehensive view, but I love that it's a normalized model too, because then it's like really you can gather this data in whatever makes sense culturally for your organization. So then DPE, I would say, follows a similar formula in that we're not exactly telling you how to do it. We're telling you what's important and why you should be looking at it, right? Now, of course, we go as far as Gradle Enterprise, and we're very opinionated about how we think we should gather the data and that sort of thing. But as a practice, we want this to be equally applicable to a C native environment, a C# .NET environment, a Java JVM environment, obviously a more JavaScript or front-end environment, any environment that involves writing code, testing code, and building code, which is very much where we're, if we were in a part of the DevOps loop that we focus on, it's that, it's design, or it's build, test, code, right? And so that's very much part of our focus. And so so anything that, so when we talk again about like the practice versus the tool, right? The practice is more like, hey, you should have something keeping track of every single build that takes place in your environment. And there are some important metrics that you should be gathering and visualizing about that build, right? And there are some aggregate metrics that you should be looking at. Failure rates across all builds, for instance. One of the important kind of pillars of developer productivity engineering, again, is consistency, reliability of the tool chain, and the elimination of avoidable failures. Developers all the time run into these like non-verification failures. Maybe they're doing an integration test and the API server's throwing 500 errors intermittently, and they've just waited 15 minutes for this part of the test cycle to come up, and then it just fails, and now they have to start it over again. Well, in real life, developers are like, well, that sucked. I better do that again. Oh, well, and then that's it. But when you're a DPE organization, that failure has been tracked, and it's been given some metadata, and it's been aggregated. So then we're able to say this one failure has impacted 200 developers in the organization over the last week. They waited 10 minutes to encounter the failure. It went across this many.
And here's how much it cost.
And here's how
that'll
much
get the
cost. Yes.
That'll get the attention of the MBAs.
The cost of inaction, or the return on investment, whatever you want to call it, of a DPE effort is such a no-brainer, James, to your point earlier, which is where you start getting into like, why would anyone object to this? And it's like, I don't think anybody really does. I think it's a consciousness thing. I mean, that's my job, really. I mean, obviously, Gradle Enterprise is a product focus for me. But my job really is more about spreading word about this practice, which is something that
I like the flaky test example, because I think it really is a specific example where every developer deals with flaky tests, right? It's like tests can be flaky, and that's just reality. And yet very few organizations actually take something like the flaky test and say, how much is this flaky test actually costing us across our whole developer organization? What is the impact of this flaky test on our productivity? Like, everyone just kind of accepts flaky tests are reality and we can't do anything about it, and doesn't actually look at what the actual cost of this flaky test is. And if we probably saw the cost, the billions of dollars that across the world we're wasting on flaky tests, maybe we would like do something about it,
I think one of the problems is that it's kind of like the compiling cartoon, is that we don't think it's an option. We think oh no, this is just this tool. That's how long it takes. We don't have any choice here. And if the idea of DPE is saying, well, you do have a choice. You can focus on these things. You can fix these things. And I would like to know, how do you propose introducing DPE, bringing DPE into an organization, and also revisit the education question that I posed earlier.
Oh yeah, sorry, I didn't hit the education question. So yeah, the first part, it starts with an emotional appeal, right? It starts with a wake up call. I almost think about it like the one little prairie dog in the cube farm who like stands up and says, I don't have to take this anymore. It doesn't have to be this way. Like, somebody has to break through and have that kind of insight, that spark that's like, wait a minute, what have I been doing my whole life? We could focus on this. We do have the ability to gather this data. We do have the ability to make this better. We can detect flaky tests. We can put them on a dashboard to gauge their priority, to James's point. So it starts by having that champion, right? It starts by having that person who says, you know what? And sometimes this is the person who brought DevOps into the organization 10 years ago, right? Sometimes this is the senior developer who spends a few hours of their week thinking about improving productivity for the team, even though it's not a full-time position for them. But it's a matter of reaching and sort of waking these folks up. There's a virtuous cycle that can occur here too, which we love to see. Hopefully this is what happens, which is where somebody can actually take this practice and use it to improve their own career path. To be able to say, okay, wow, I am now a productivity engineer and I make these wonderful contributions to the organization by reducing this cost, reducing this risk, improving the brand, and all these other things. So it can actually, and if you think about the heroism involved in a position like that, I always like to tell people, think about who you could have been to your company if you were the person who brought in DevOps 5 years ago or 10 years ago. Good news. DPE is new. Netflix only started doing this back in 2017. LinkedIn started doing this back in 2018, right? It's still new enough that you haven't missed the boat on it. You can be kind of a pioneer in thinking about this. So it starts there. It starts with a champion. Then start with a project, right? It depends on the level of effort that you really want to put into doing that pre-research. But ideally, you want to pick a really problematic project, right? Ideally, you want to look at a project that's got an hour plus build and test cycle time associated with it, that has known flakiness, known inconsistencies in the build. Start with something like that. But I do say make it a single project, because there's a number of vectors that you're going to have to come in to actually sort of improve this, right? On the acceleration side, you're going to have to look into which acceleration solutions might be viable for your code base, for the language, for the framework. Does your build tool have a build cache? Can you do build caching, for instance? Caching individual phases of the build so that they don't have to be rerun, a second time. Are you able to distribute tests, right? Whether that's through CI fan out, or even better than CI fan out, can you set up like JUnit runners inside of a Docker image that you can throw at a horizontal pod auto scaler in Kubernetes and elastically scale the way the tests are determined? Can you predictively use a model as opposed to manually determining which tests should be selected per run, right? So can we apply any of these acceleration technologies to the build? Great. The observation, the analytics, that's almost like the first step. I mean, really, I for anybody who's kind of looking at me glazed over after having a DPE talk, they're like, I want to do this, but I don't know how, then it's like, start with the measurements. Just start with the measurements. Go look at your build scripts, find a way to yank that last bit of data out. How long did this take?
Do science on it.
Do science on it. Yeah. Start, because it's ancient, multiple 1,000-year-old wisdom that what gets measured gets improved, right? And that's a good place to start, is just with that instrumentation and gathering some of that telemetry about what's actually happening with this build, because generally that's enough to start driving interest beyond, the first person to kind of put this in. Because as soon as you do that, and then maybe you take a look at, I don't know, let's say that this is an hour-long build, but we did, in the case of Gradle, we did a build scan on it. It was a Maven build, and we found out that 90% of the build tasks were cacheable. And now we're able to say we're wasting 90% of an hour waiting for this build to complete. And we're doing this 2,000 times a week. Once those numbers are out there, it becomes really hard to unsee. It becomes one of these things where you look left, you look right, and you're like, wow, we are just like bleeding over here. And I didn't even know this yesterday, but now I can't stop seeing it, right? But those are actually very typical reactions. I mean, like, especially when you start with folks who are maybe already doing DevOps for an organization, there's generally, like, I'd say kind of three audiences that we sort of address, right? I mean, obviously the Java user practitioner community. Hey, you deserve better. Let us help you get there. Then there's their bosses, right? Hey, your employees deserve better. Let us help you build a better experience for them. But the DevOps crowd is really compelled by DPE as well. I'll get in front of a DevOps audience, and I've had feedback where people be like, oh, it was a great talk. I learned so much. But it was also the most frustrating talk that I've heard in years, because I'm listening to everything you're saying and just kicking myself that we weren't already doing these things, right? So a lot of times that's enough to kind of catch fire in the organization, is just to start taking those measurements and showing them to somebody. But then really, you start with that first project, you see the success with it. The developers are happy. They think about going to the world before, after you make these improvements. They're like, I never want to go back there, man. And then, it tends to be a thing that then kind of scales throughout the rest of the organization. Now, if I had it my way, if I was coming in and had the type of power within an organization to enforce this on day one, I would actually start with the team. I would actually start delegating a core team of DPE engineers whose job it is to go through, seek opportunities for these improvements, cascade those improvements, be accountable for those improvements, and then continue to drive the efforts throughout the organization. It's much better to have that focus.
So, question on do you have a way to think through? So let's say that we're starting to get all this data around like incremental builds are terribly slow, full builds, CI builds are incredibly slow, flaky tests are costing us X. Somebody is breaking the build, X number of times per week, whatever, and there's a cost to that. So you start to like get the information about where the things are broken. But then there's this other step of like, okay, what should we tackle first? Or how do we prioritize these things? Like, how much work is it going to take to fix X, and how much return are we going to get on that work? Do you have any model for kind of that, I guess, that prioritization of once you've identified the broken things, how do you then decide what to fix first?
No, it's a great question. In general, and of course, it's not always this clean because you have to always, there's always this, is it a super high risk application? Is this like one of these critical applications that touches everything else in the entire business? In which case you may see a huge impact from improving this application, but it may also come at a fairly high risk, right? So, again, the nice part about sort of instrumenting all this, there are things that you can look at in the build that can give you some clues as to how much impact one of these acceleration technologies is going to make. Like, for instance, going back to the JVM side of things, but even the free build scan tool that's out there that's available for Gradle and for Maven and for Bazel gives you information on the cacheability of the different phases of that build. So, like, say you get a Maven project, and that Maven project has 3,000 goals, let's just say. A single build scan can actually tell you, all right, this project has 80% of its goals that are cacheable, right? We turn on a local cache, we should be seeing this amount of savings, right? So typically what we'll do is we'll say, apply this to multiple projects, and then turn around and say, what's going to have the most impact? Then of course you balance that against the risk, right? I don't care if it's like, you have this project where it's like, oh my God, we can save 99% of the build time, but it's the most mission critical project that we have in the whole company. And it's whatever, an API center point for everything else that runs. And so we turn this thing off and everything else crashes. Maybe you don't want to start there, right? So you want to look first at where you can really see the most.
Some investigation that needs to be done into like taking the information that you get out of the tools and then figuring out how to best apply
prioritize
it.
Based on that. And most of these changes can be done with very little impact to the code base itself. I mean, most of them is doing things like normalizing task definitions in Gradle, or normalizing goal input and output in Maven, right? Which is all about manipulating build scripts and not really manipulating the code. So,
right. Yeah, so it does seem like the tools can help you kind of simulate or identify what the hotspots are, or how things can be better. Like cache invalidation seems like a fairly easy thing to be able for a tool to go in and be like, hey, like you are invalidating this cache over and over and over again because of X, and that should be a pretty simple fix.
It's usually things like, this is a normalized task that's cacheable usually by the local cache, but you're generating timestamps in source code. Part of your build is generating source code. You're putting timestamps in there. So technically the inputs to that part of the build will have changed, and you get to your point of cache invalidation or a cache miss at that point. But all you'd have to do, is either normalize that timestamp or not use it anymore or something like that. And then suddenly that task becomes cacheable. There's other things too. I mean, there's just architecture is important here too, right? The more modular the project is, obviously, the more impact a cache will have. If you think about the way the caching works, right? We're taking inputs to a goal or a task or a target. And these inputs are things like source code, class path, JVM major version, things that kind of give us an accurate context of what's going into this input. And if we generate a hash from that, and if the input is identical, further down the road, then we take whatever the output from that cache was, that task was that got put in the cache, and we use that as opposed to actually rerunning that part of the build, right? Which is how the build caching works.
Yeah.
So there are some things that you can look.
Well, then there's the doing this locally and then doing it across an organization, which are kind of two different levels of cache that you could implement. And my guess would be that most folks in the industry of software are not doing the shared cache across multiple users, because that gives you a whole nother level of productivity. It's like, okay, one person did this calculation, now no one else should be able to do that. And this is some of the stuff we've talked about with Unison, and some newer technologies kind of do this inherently, but it is possible to apply this to kind of more existing tools, than not have to switch your whole programming tool chain and programming language to take advantage of this.
Yeah, that's where we usually say, like, look for the availability of a cache in your build system. Like, Gradle introduced local caching to the JVM world and the Java world back in 2008, maybe later than that, actually. It was actually later that the local build cache came in, so I couldn't give you the exact number on that. But we build systems like Clang had build caches before this, right? So it's a pattern that's fairly well understood. But the nice thing is that because it's this elegant solution where we generate a key, a hash based on these inputs. To your point, a remotely distributed cache for a team that utilizes CI and maybe a follow the sun mechanic, it could be extremely helpful. So if you think about this, you have a team that's working overnight, working on the same feature branch that you're working on, whatever it is, and they're populating this remote cache with their with cache outputs that are coming from their build. Normally, you're coming in 8, 9 a.m. You're pulling down all the changes that got made overnight from the offshore team, and then you're sitting in for a long build, right? A long, clean build based on all the changes that came in the night before. Or if you're using a remote cache, you're actually pulling a lot of those tasks that were run under identical conditions by the follow the sun team, the evening team that came before you. And so you're actually taking advantage of that cache during the first clean build of the day, which is unheard of, right? And again, going back to these like patterns that we just accept, why is it okay that like the first action we take of the day should be to waste an hour?
Right.
So as my first executive decision of the day, I'm going to do nothing for an hour. So.
But hey, if you fix this problem, then people are not going to have that opportunity to go get their coffee after they start the build.
That's actually the number one objection we get, is that I like calling my mom first thing in the morning. I like brewing my coffee.
Catching up on Twitter. Yeah.
It's like, well,
whatever.
Guess what? You can leave early. So.
Yeah. So then what about this realm of having your CI servers use machine learning to pick tests?
Oh, yeah.
Because the way that CI typically works today is that you maybe have different phases of tests. You've got like the quick tests and then the full test, whatever, but we've kind of created this stacking of tests, when it seems like maybe a better way is for the system to learn what tests are likely to be needed to be run, instead of just taking this like blunt hammer to it every time.
So yeah,
so it seems like there's been some innovation there. Tell us about how that comes into DP realm.
This is one of the more exciting areas, starting to actually use real machine learning for real problem solving, as opposed to just having it in the loop just to have it in the loop. So this was actually not something that we invented. Google, Facebook, Microsoft have all been working on various incarnations of this. And Meta, Facebook, was the first to get to academia with it by publishing a paper back in 2019 that they called Predictive Test Selection. And in that paper, they laid out how to build these mechanisms. And you can do it using totally open source frameworks. In fact, they used the XGBoost gradient boosted decision tree model, which is nice too. It's not a deep learning model, which means you don't have to sit there and install like an NVIDIA GPU like next to your build tool chain to take advantage of this, right? It just runs on typical CPU. And what this does is it looks at historically how source code changes have impacted test outputs in the past. Different types of changes. So the different types of changes are given different features, and the model is trained against those features. And over time, what you end up with is a system that predicts, okay, well, based on the changes that you just made, I know that you got these, incrementally selected 20,000 tests that probably should execute because they somehow touched the code that you just touched. But the model is only predicting that these 30 tests have any high likelihood of changing their outcome from the last time that they ran, again, because we have all this historical data that we're capturing. So don't bother running them, at least pre-merge, right? Post-merge, please run everything, but pre-merge while you're making incremental changes locally in your environment. And so that's another important thing here too, is that you mentioned that this is bound to CI, but what's actually interesting is that a properly implemented predicted test selection model should be bound directly to the build tool and what's ever actually scheduling the test sets. So it can work in CI, but also work locally, which is really key. I should have worn my shirt. Actually, well, we're not recording the video, but I have a shirt that says build local instead of buy local. It's like one of our, it's like kind of our little pet campaign. And this came out of conversations that we were having with, I think it was Atlassian. We were talking about productivity, and we were saying, well, what are some characteristics of a development tool chain that's very healthy? Like, what do you consider to be very healthy? I'm like, well, if you can do everything locally, right? I mean, if you can do everything locally, your test sets, all these things, then you're getting your feedback as close to the developer as possible, right? And you're not relying on external systems to deliver this feedback to you. So predictive is built to actually plug right into where the build automation is selecting a test set, passes that test set as well as the inputs into the model. That model extracts the features and then makes the prediction. And then only the tests that come back from that prediction are actually run. Then the outcome of those tests is passed back into the model. So it's continually retraining itself too, which is really nice. The net of this though is that, right now we tend to manually select tests. We're like, all right, I worked on this little part of the app. I'm just going to turn off these tests because I know I didn't touch any of that stuff, right? Whereas predictive says it just takes that. You don't have to think about that, right? Predictive just says, okay, looking at this history, these are the only ones that are likely to provide any valuable output for you. And then where we've implemented it, we have a usage dashboard and a simulator dashboard. The simulator, I think, is really important. The simulator can just be turned on and sit there and say, I would have only selected these tests because I only think that these are the ones that would have changed their outcome. And then it can generate a confidence score, right? We're able to say like, okay, well, actually running these tests, we found out that we were right 99.8% of the time, right? These are tests, right? I mean, it's dicey, right? You don't want to you want to project a good confidence to the developer so that they trust the model enough to rely on it to skip tests. One of the interesting things about the way that we implemented, something that we're pretty proud of actually, if you look at some of the initial measurements that came out of the academic reports, a lot of these engines were only hitting 80, maybe 85% confidence, which is good enough in some cases, given the amount of time savings that you get and that you're still doing post-merge running all tests. But what we found, we started looking at this, training the model. A lot of people were training the model based on flaky tests. And what happens when you train a model based on something non-deterministic? You end up with a non-deterministic model, right? And so these lower confidence scores were coming out of other people playing with this stuff who didn't already have a mechanism in place for detecting and filtering flaky tests. So we actually combine both of these things.
Knowing whether something is flaky is an important piece to the model,
and
right?
If it's been listed as flaky, then we don't use it to train the model. That's how we were able to get from the 80, 85% confidence scores up into the high 99th percentile of confidence scores, which is, it was fascinating. It was really an interesting thing to watch kind of evolve, because it was like, why can't we get,
I love that the history of that. Like traditionally with tests, it was up to a developer to mark it as flaky and then do something about it. But it's like, no, like the system should know if over time something is flaky and know what to do about it. And to me, that just is a great example of like DPE learning and getting us to a better outcome that kind of removes developers trying to I don't know, likely doing the wrong thing. It removes that from the equation. It says the system can know and make the right decisions and has the information to do so. Let's let the system do it.
Let's let the system do it, and because it's a gradient boost, I should have mentioned this too. Beyond the confidence that we're able to exhibit through the simulator, because it's a gradient boosted model and not a deep learning model, it's actually highly explainable. It's very, very easy for the model to say why it made the decision that it made. So even in our dashboard, we have a justification. If a test gets skipped, you can highlight over it and it says, oh, well, we skipped this because the last 20 times it ran with the same source code, it was successful, or we selected this test because it failed once in the last 10 runs or something like that. And it could be problematic, right? So it's a pretty smart model, but it's very exciting because it's one of these things that, first of all, uses machine learning for a real, tangible, concrete problem, but then delivers on the promise of machine learning, which is literally reducing the overall amount of work that has to be done. This has, we didn't, and there's so many different angles that we, kind of didn't get into, but, beyond being able to improve developer experience, we're experimenting with messaging to HR professionals, because what we're talking about is actually something that improves wellness and is something that could be, useful for employee acquisition and retention. We have messaging that we think can transcend a lot of what we've been talking about here and move into things like sustainability. We've had feature requests from multiple customers to say, hey, could we get a dashboard that shows us our carbon footprint savings from using caching and from using predictive test selection? Because these are things that are actually reducing the overall cycles that the tool chain is running. So because what we're really talking about is efficiency here, there are so many cascading impacts, to an organization who actually puts this into practice. We didn't talk about CI that much either, but most of what I like to focus on is in that developer experience realm. But because so many businesses are sort of numb to these problems and people aren't complaining, a lot of the times these problems are manifesting in CI with agents that are always tied up, wait times waiting for agents to pick up jobs, or jobs that take too long to execute, or jobs, again, inconsistent and reliable. But all of these things that we're talking about here that apply to the local developer experience also apply to CI. So sometimes what you see is an organization whose immediate symptoms of putting the immediate symptoms are actually more related to CI inconsistency and inefficiency. You put this stuff in place, you put in predictive, you put in caching, CI benefits from that as well. Suddenly, half of your agents are available all the time. You may even be able to downscale your CI and save some money. So, again, there are these cascading impacts that are not always immediately intuitive that come out of a result of introducing all of these efficiencies.
It's like you make things better for the single developer, and that ends up making things better for everyone in the organization as a whole.
In the end of the day, this is getting back into theory of constraints, but I love this stuff. The theory of constraints and the Goldratt equations are something near and dear to me. I think they're some of the most important and some of the most important business literature that exists. But when you start getting into anything that will simultaneously decrease the cost of a system and increase its throughput, you have a winner. You have a no-brainer. That's why we kind of like to put ourselves, as far as DPE is concerned, we see ourselves historically as very related to DevOps and Agile and Lean and business process reengineering and just-in-time manufacturing and all of these, big breakthroughs in productivity in the past. Because this practice shares the same thing that those practices share, which is that in almost every case that they're implemented, they decrease the cost of a system while simultaneously increasing its throughput. And, that's textbook, the goal 101. You have an action or a practice that does both of these things. It's going to win. Simple physics denotes that it's going to win. So,
yeah. Do you imagine that there's a future where people look at that XKCD comic and laugh and be like, oh, remember those days? Oh. Can you believe that, they had to use rocks to like hammer things? Is that a possible future, or is there just an endless amount of things to do to make this better?
I'm realizing how short-sighted I've been, because I felt like my tangible goal was to just have DPE as an established product category. But now I think the real goal is to make that cartoon irrelevant. That's how I will
Yeah.
gauge myself going forward, James. So,
Good.
yeah, no, I hope so. I really do. I mean, we can't keep doing this to ourselves. We have a relative dearth of developers compared to the amount of code that needs to be written for the world to realize its digital transformation efforts. We're only going to have a greater and greater reliance on this workforce. So the thought that we would continue to allow all of this waste gives me a lot of heartburn. Like, I really hope that we can get to a point where we're thoughtful about this and we're improving it, because I don't know that we're able to meet these goals without starting to introduce some of these efficiencies. The demands are higher. The amount of code we need is greater. The amount of things that run code, is just, exploding. And so I really hope that we can get to this point. And I think that we take on a lot of debt if we don't. What gets me out of bed, what gets me interested in talking about this, is what this could do to our quality of life from a digital perspective, practiced at large. If every organization, which is now a stakeholder in creating software, every organization was innovating at 10x the clip that they're innovating now, what does that do to the world around us? And when I was primarily evangelizing open source in the enterprise in my previous role, that was the same type of drive. If we can get every business in an open first mentality, how does that accelerate the global pace of innovation? And I would go and say these things, and it got to the point where it was like, oh, open first. Yeah, thanks, Justin. Yeah, we've been doing that for a couple of years. We know. So it's like, now
Right.
I feel like we have this next practice that can be another accelerating.
Open source made a huge impact on our ability to innovate faster, and maybe DP is the next frontier in that realm, right?
That's our
Yeah,
hope.
a couple
That's
things that come up for me during this conversation. One is that I didn't know, when I was working for companies, I didn't know what I was really looking for. And I think now it was developer experience. Well, just the whole experience, what kind of experience do you have working? Is this a pleasant place to work that I look forward to going into? And the other thing is that if I was starting my career now, I wonder if I wouldn't have ended up in developer engineering, developer
productivity engineering.
what you're doing. Yeah, exactly. Because my focus has always been mostly on languages, but the interest in languages has always been, how do we be more productive? How do we do more with less? And you're talking about, well, let's look at everything around the development process, not just the language.
I think you're right, though.
Languages are just like one avenue of improvement, but there are many others.
You want to know what's kind of interesting? Going back to the coding war game study that I was talking about earlier, one of the non-factors for productivity in the organization actually was the language, with the exception of the first generation language, like assembly. Obviously, the assembly folks they took a lot longer, but newer generation languages, at least back then at the time, in the mid 80s, when there was no statistical data correlation between whether somebody was using, I don't know, COBOL or C. They were producing at roughly the same clip. So Fortran, or I'm just trying to pull out stuff from. But no, I think you're right, Bruce, and it is like, it's not the mentality of every engineer or every developer. It really is a very specific, I think, special personality who is able to kind of see the forest from the trees. I think, and I do think it comes down to, I'm a big fan of another book that takes physics and applies it to businesses. It's called Organizational Physics by Lex Sisney. And another really great piece of literature that, if you're like me, if you're geeky and sciencey but you're also in business, it's this really great merger of taking, physics and applying it to the way that businesses work. And they kind of organize workers into these 4 different categories, forces, they call them, into 4 different categories. One of those categories is the producer category. And this is the person who wants 10 years worth of work in front of them all the time. They want to make sure that they're, I got that full pipeline, or they do not feel comfortable unless there's just mountains of work ahead of them. That's where they feel naturally comfortable. That's a lot of engineers. I really think a lot of us, it's the way that our minds work. We want that work. It's satisfying to us, and it keeps us in our comfortable state, right? I personally get paranoid when I don't see enough work ahead of me, but I think that what you're actually talking about, the type of personality who would have this focus more on efficiency, is what you call a stabilizing personality. It was what organizational physics calls a stabilizing personality, which is the person who actually enjoys putting process around things, or actually enjoys paying attention to the performance of the tools that are being used. Naturally, their inclination is to be critical of these things and ask questions about how efficient the system really is, and could it be better, right? But in our industry, you tend to see a lot of producers, a lot of innovators. Stabilizers tend to be thought of as someone difficult to work with in our industry, because they do ask those difficult questions. It's not always just an easy, let's crank out some code and just see what sticks,
It's why are you doing it this way?
Yes. Yeah. Simple, right? And I mean, and it's very important. It's very important. So, but I think you might have found your way into, hey, never too late. It's a new practice. So, you can jump in feet first now. So,
well, yeah, the thing that keeps coming to mind for me is that, as we've heard, software is eating the world, but it seems like there is something that is getting us further and further behind in that, in what's happening there. And I hope that DPE will accelerate this so that software really truly can eat the world and keep up as it needs to. Because just like selfishly, like most software is really horrible. Like it's why my phone gets so many app updates that say bug fixes and performance improvements. It's like, why? Like can we stop fixing bugs and actually do useful things?
Right. And it's still too hard to make, because I look around, people go, oh no, the AIs are going to write all the software. And I'm going, great, nope. Because I mean, we look at the bookstore and they have this antiquated software. And I'm going, we're not making it good enough, fast enough. And it's not a problem of our jobs going away. It's a problem that we're not able to easily enough create the systems that need to be made.
We don't deserve it. The bots deserve it. No, it's an interesting thing with the GPT and the code generation, because on the one hand, there's no question that something like a GitHub Copilot falls under what I would consider to be developer productivity engineering. No question, right? I mean, you're eliminating toil, you're helping, and you're using technology to do that. But it's still, you can ask it to go, sometimes like write a historical essay about an obscure piece of history, and it will, with the utmost confidence, tell you something that is completely false, because it has zero sense of shame or personal accountability for what it's telling you. And so,
like
some people I've heard of, yeah.
people have.
It does not feel shame when it gives you code that is buggy.
Yeah, but people have no excuse, right? But bots, at least they can say that they were biased or whatever. But so that what frightens me a little bit is that, at the cost of productivity kind of always comes criticality to a degree. Like a perfect example, I think, of this is the open source supply chain. As big of a fan of this as I am, the amount of code that we put into our systems that we are completely blind to its functionality at this point is, again, really eye-opening. I mean, I remember coming up, you coded everything, and it was even like an honor badge. Oh man, I cranked out like 200,000 lines of code last night. And it's like, now it's like, God, why would you ever do that? Why wouldn't you just use Spring or something? And the amount of faith that we put into these dependencies that are not code that we own, it's not code that we wrote. Like, but again, we kind of blindly take it because of the impact that it has on our productivity, efficiencies. The same thing I'm concerned can start happening with AI generated code. We become very reliant on this to the point where we're not being as critical as we should be. Who's reviewing the bot? Maybe we could have bots reviewing the bots. I mean, that would be great too, but there's still quite a bit of work to do, I think, before we can really be confident in that. So, and maybe it reduces the amount of drudgery, I guess, or the amount of typing that we do, but then allows us to focus more on quality and architecture and things that a bot won't have a critical eye for. So yeah, it's a fact. Yes, I never say never, right? I know better than that. So.
Well, and to Bruce's point earlier, it's like what many of us desire is to enjoy our job. And when I get into a long feedback cycle, like I did for the last 3 days, trying to get GitHub Actions to build ARM images, and the cycle time on testing my one character changes in my GitHub action was 45 minutes.
No.
Like, I just want to pound my head against a wall repeatedly, because that's what it feels like to make a change and wait 45 minutes to see if it actually worked. That's not enjoyable.
No.
And hopefully with DPE, and I'm sure other things, we can get to places where we as developers enjoy our jobs more. And AI is, I think, certainly part of that as well. But how can we focus on the enjoyable things? That's I think, where the central piece to all this.
It's an extra. I mean, that is our deepest value, I guess. If we were to sum it up in one, they don't need a full sentence. It's just joy equals productivity. That's something that we've actually used internally. We've used it as our own value, core value. Something that as I start fleshing out more of the DPE, spoiler, we're going to be looking at like more DPE.org type of stuff, manifesto-y type things, to try to really drive this. But that's a core value right there. That joy and productivity are really the same thing, when it comes to the developer experience. Happier developers write better code. They write more code because they're in their state of creative flow and they're acting optimally. And so again, it's this really virtuous thing where they're doing a better thing for the business, but they're doing a better thing for themselves too.
Nice.
Wow. I love that. Yeah. That is a wonderful thought to end on.
All right.
Yeah.
Thank
you, Justin.
My pleasure.
That was awesome.
My pleasure. This was great. Yeah. Any time I'd love to. I always love to talk about this stuff, obviously. So.
Clearly.
Does it come through?
It does a little bit. A little enthusiasm.
Just a little.
Oh, awesome. Great. Well, thank you.
Thank you. Appreciate it.
And everybody check out the wintertechforum.com website. Come to the Winter Tech Forum.
That's right. Winter Tech Forum coming up end of February.
Yep.
I'm going to go look at that.
And in Crested Butte, Colorado. Justin, we'd love to have you.
I'm looking at it now, actually. This seems it's a whole open spaces. Oh, this seems really
It's all
cool.
open spaces. It's all discussion.
Butte is a beautiful area too. And I don't think that we have a conflicting conference during that time. So
well,
all right. Thanks.
Well, hopefully you can join us.
Yeah, I would love to.
All right. Have a good one. Thanks, Justin.
Thanks all.